This is going to be chapter 8.1, the law of sines. So far we've been talking about trigonometry and kind of basing everything off a right triangle with a 90-degree angle. So that's kind of how everything has been set up. So now what we're going to do is look at different triangles that maybe are scalene or isosceles or something completely different. So that's where the law of sines and also the law of cosines comes in. So here I wrote down two different triangles. They're basically the same. It's just that we labeled them differently. So you can see that the ones that are lowercase, A, B, and C, all of these guys are the sides of the triangle. So these sides just tell you how long how long they are. So there's nothing really in particular to really know about, but usually it's just A, B, C. Now, sometimes you might have your angles labeled a little bit different. So notice here, your angles here are um, are the capital letters. So sometimes it can be the capital letters A, capital B, and capital C. So that denotes the angles and the insides or the measures. And then you can also have them in Greek letters. So you can have alpha, you can have beta, and you can have gamma. So depending on the book that you're using, and I think the book uses this guy, but I like using ABC. So you can choose whichever letters you want. Just I want you to kind of just know that sometimes there's some books that use alpha, beta, gamma, and there's also some that use capital A, capital B, and capital C. Now, one of the good things about this is that whenever I say A, if I say the side is A, then right opposite to that will be the angle, capital A. Notice also the same thing for B here is side B, so the angle opposite to it will be big B, and same thing with C. And we're doing the same thing with the triangle. So here is side A, so the angle opposite will be alpha. Here is little b. The angle opposite to that will be beta. Oh, there should be a beta. Oh, it looks like beta. So here is C. The angle opposite to that will be gamma. Okay, so gamma is kind of like a funky looking one. You can just draw like little vegetable. I don't know. Okay, so this would be gamma. When we talk about triangles, sometimes the triangles themselves are going to be very different. So very different than the way that they were in the right triangle. So there's no Pythagorean theorem here anymore. So Pythagorean theorem is not going to be helpful anymore. So now we have to look at some of the triangles. So sometimes you might have something called SAS, which means side angle side. Okay, so when you have side angle side, that basically means that the triangle that you have is a side, an angle, and a side. So those guys are known. So those three things are already known to us. So side, angle, side. You can also have angle. Oops. ASA, which is angle, side, angle. Okay, and basically what that means is that if I have a triangle, then you have an angle, a side, and an angle known. Okay, so it can look something like that. You also have something called side, side, side. Okay, so that means that you have all sides known. Okay, and you also have something called angle, angle, side. Angle, angle, side. Which means in that case that you have two angles known and then one side known. And they kind of go in clockwise or counterclockwise direction. So you can't say that this is I don't know. You can't say that's angle, angle, side. This will be angle, side, angle. Okay, so they have to be consecutively. Now you also have other weird cases. The other weird case, so actually, before I continue with the weird cases, these guys right here, 1, 2, 3, 4, I think I got all of them. Yeah, these guys guarantee you a triangle. So the triangle will exist. Now, sometimes you're going to have weird cases, which is going to be like the side angle, or how I like to say ASS, because they're a pain in the ass. These are basically the side angle, or angle side. These are the weird cases, which we'll talk about later on. So this is a weird case. So when you have a side, and an angle given to you, weird things tend to happen. So this guy right here is super weird. And sometimes with these triangles, you can have one triangle, two triangles, or none. And I'll show you how you can know how do you get which ones. And we'll go a little bit in depth about what that is. And probably you've seen it in trigonometry as well. So we're going to revisit it a bit. So one of the ones to kind of just note is that angle does not exist. So angle. So angle, and angle. This guy just does not exist. So we do not know what that is. Okay, there's no way that we can ever know what this guy is. Let me just draw 3. So there's no way that we can figure this out because we don't know anything about the size. So so if I were to give you, or let's say alpha is 20 degrees, beta is 60 degrees, and then gamma is 180 degrees, and I give you this as an example, and I tell you find the other sides, well, you can just say that this is impossible. There is no way that you can create a triangle just by giving the measurements. Okay? So basically the goal for these types of problems, so let me just write the goal of this, is basically to solve a triangle that is not a right triangle. Because if it was a right triangle, then we already know that's just going to be the Pythagorean theorem. Okay? So what do we need? So basically, let me write down, what do we need? So the thing that we need are basically 4 different cases. So you're going to have case 1, which is when you have side angle, or angle side, or angle side angle. I don't know why I wrote side angle. You can write angle side. I think that's better to write. You can write side angle if you want. So if you have angle side or angle side angle. Okay, so basically you're given 2 angles and 1 side. Okay, that's going to be case 1. Case 2 is going to be SSA, or the ass case. So this is a weird case. Okay, so basically these 2 right here are going to be something called the law of sines, which is what we're going to talk about in this video. The other guy, case 3 and case 4, so case 3 will be the side angle side, and case 4 will be side. So if you have those forms, then the best method to use will be the law of cosines. Okay, so that would be kind of like the best way to go about that. All right, so let's start off with the law of sines. Now there is a derivation to this formula for the law of sines. I'm not going to derive it here because it should have been derived for you a while ago. But if you want to know the derivation, it's actually not that bad. But I won't derive it here. So basically what the law of sines says is that given a couple of angles and a couple measurements, I can figure out all of them by doing the following. Taking the sine A over little a, sine of B over little b is equal to the sine of C over little c. Okay, this is the law of sines. Okay, so here in this case, A, B, and C, all these capitals, are angles. Little a, little b, and little c are all side measurements. Okay, now if you're using the alpha, beta, gamma then it'll be sine alpha over little a equals sine beta over little b equals sine gamma over little c. Okay, so if they're both the same, it's just I'm just changing the a, b, c to alpha, beta, gamma. Okay, all right. So now what we can do is let's go ahead and do a problem. Okay, so that we can kind of understand how we use the law of sines. To do the law of sines is pretty basic. So we'll do the case 1 really quickly, because the one that I really want to focus on is case 2. So we'll do something with case 1. So let's do an example. So solve the triangle. Solve the triangle ABC if A is equal to 28.8 degrees, big C equals 102.6 degrees, and little c is equal to 25.3 inches. Okay. So the first thing that you kind of want to do is you want to draw this triangle. Let's go. I see that C is a little bit more than 90, so it kind of will look something like this. So you kind of have like an obtuse angle there. So now let's just label it. So this is clearly going to be C. So this is 102.6 degrees. If this is big C, that means little c is right across from it. That's going to be 25.3 inches. You can label this triangle however you'd like. Okay. Then we have A. I'm just going to say this is A. This is going to be 28.8 degrees. So that means across from it should be little a. And then this is going to be big B. I don't know what big B is. So then across from it will be little b. So you need to kind of figure out, so what are the things that are missing? So I don't know what little b is. So that one's not, I don't know what that is. I need to figure out what little a is. And I need to figure out what big B is. Well, one of the first things that we can do is that we can try to figure out what big B is, so the angle of B. And notice that everything should add up to 180 degrees. So the whole thing is 180 degrees, so I'm going to subtract the addition between the two angles in the middle. So it'll be 102.6 plus 28.8. Okay, so let me go ahead and do that. So you're going to get 180 minus 102.6 plus 28.8. Okay, so that's going to give me 48.6 degrees. So we just figured out what that one should be. Usually if you have two angles and then you're missing the other angle, it's really easy to figure out just by taking 180, because that's the whole measure of the entire triangle, and subtract it by the addition of the two other angles. Okay, now we need to figure out, so now you already know what B is. So this B is going to be 48.6 degrees. Now I need to figure out what A and B is, little a and little b. Now one of the things that I can do is that, well, I already know what the C values are. So I can use these two C values to try to figure out the other guys. So I can use sine big C over little c is equal to, well, now let's pick one of them. Let's pick, I don't know, A. It's going to be equal to sine A over little a. Okay, so I'm going to pick these two pairs. You don't have to look at the other side, at the other sign. Okay, we can just do this. So now this is going to give me sine C. So sine C in this case is going to be 102.6 degrees divided by little c, which is 25.3, is equal to sine A, which is going to be the sine of 28.8 degrees divided by little a, which I don't know what that is. So here what we can do, we can cross multiply. And you're going to get A sine of 102.6 degrees is equal to 25.3 sine of 28.8 degrees. Okay, so I'm going to divide by the sine of 102.6. Okay, so then A is going to be approximately equal to, so I'm going to make sure that my calculator is in degree mode. And I'm going to go into my calculator, so I'm going to have 25.3 sine of 28.8 degrees divided by the sine of 102.6 degrees. And that's going to give me A equaling 12.5. And it's going to be in inches. Okay, so I figured out this guy. So this guy was just 12.5 inches. Now I need to figure out what B is. Now the most common mistake is that a lot of students want to use Pythagorean theorem once we figured out what A is. That's not right because this is not a right triangle. So that means we have to use the law of sines again. So now this time we're going to use sine C over little c is going to be equal to sine B over little b. So you could have used sine A if you wanted to. It doesn't really matter. So this is going to be sine of 102.6. Oops. Degrees divided by 25.3 is equal to sine B, which I know what that is. That's going to be now 48.6 degrees divided by little b, which I don't know what that is yet. So again, I'm going to cross multiply. So I have B sine of 102.6 is equal to 25.3 sine of 48.6. So I'm going to divide by the sine. Divide by the sine. So I'm going to get B is going to be approximately equal to, so I'm going to have this 25.3 sine of 48.6 divided by the sine of 102.6. Okay, and that's going to give me 19.4 inches. Okay, so this one's going to be 19.4 inches. Okay, and that's basically it for this guy. So to do the law of sines is very self-explanatory. There really is not much to it, especially if you have these cases. So if you have two angles and one side, it's pretty easy to figure it out. Because basically, if you have that case, the first thing that you want to do is solve for the other angle because you have two angles. And then basically, though, for the rest of it, it's just use the law of sines twice, and you'll be pretty good with the case 1. Now, case 2 is going to be a little bit different, and we're going to do that in the next video.